When you look up at a giant video wall showing a flawless live game in 4K at a sports bar, you're actually looking at data beamed directly from a satellite orbiting like 22,000 miles in space. Today, we're looking at the exact invisible piece of hardware that catches that space signal and turns it into the internet data running that TV screen.
Yeah, we're doing a deep dive into a product page from HDTV Supply. It's for the Vitec AVSTR-G TVgateway. And on the surface, it looks like this completely dry technical spec sheet, but it actually decodes how modern enterprise AV infrastructure fundamentally works.
Okay, let's unpack this. Because an AV gateway, I mean, that sounds like something out of a 90s cyberpunk movie.
Yeah.
So what is this device physically doing when that satellite beam hits it?
Right. So at its core, it's basically a receiver and a converter. It takes uncoded live TV and radio straight from the satellite.
Straight from space.
Exactly, straight from space. It physically connects via inputs called DVB-S and S2, which are just the, standard formats for satellite broadcasts. And then it takes those raw signals and streams them across your local IP network using protocols like multicast and unicast.
Okay, let's pause on those terms for a second, because throwing around multicast and unicast can get confusing fast.
Yeah, absolutely. So think of unicast as like a one-to-one phone call. If a sports bar has 50 TVs, a unicast system would send 50 separate, really heavy video streams over the local network.
Oh, which would just instantly crash it.
It would totally crash it. So multicast is more like a loudspeaker. It sends out just one video feed, and all 50 TVs tune in at the exact same time without adding any extra strain to the network.
Oh, wow. So it's less like a simple translation and more like catching a continuous waterfall of radio frequencies from space and instantly bottling that water into millions of perfectly identical digital bottles.
Yeah, that's a great way to put it. Digital bottles that the local network can just hand out to individual TVs.
Right.
And it uses standard protocols, UDP and RTP, to ensure those digital bottles stream smoothly, in the right order without skipping or lagging.
So looking at the specs, this specific model, the G4410, it boasts like 10 times the bandwidth of the previous generation.
Well, it has to, standard definition is basically dead. This machine is built to handle 4K, Ultra HD, and HEVC streams.
The HEVC.
Right, high-efficiency video coding. It's this advanced compression standard that basically squeezes massive 4K files into manageable sizes without ruining the picture quality. Pushing that much visual data in real time requires immense processing power.
Wait, I'm looking at this picture, and it explicitly says it features low power consumption and a built-in power supply. But right underneath, in bold, it warns chassis required.
Yeah.
That seems totally contradictory. I mean, if it runs efficiently and has its own power, why can't I just plug it into the wall of my desk?
Well, you really wouldn't want it on a desk. The chassis requirement means this device is actually what's called a blade.
A blade.
Yeah, it's a modular unit designed to slide physically into a massive centralized server rack in some back control room. While it manages its own internal power flow efficiently, these individual blades don't have their own heavy power bricks or large cooling fans.
Ah, so they rely on the chassis for the heavy lifting.
Right. They plug into a shared, massive power supply and a unified cooling system built directly into that chassis. That architecture is what keeps the whole server rack efficient.
That makes sense.
You might have 10 of these blades stacked side by side, pulling down dozens of satellite feeds simultaneously.
But if you have 10 of these blades stacked together handling dozens of 4K streams, managing that much data must be a total nightmare. I mean, how does one IT person actually control all this routing without dropping feeds?
It's all done remotely. IT professionals control this hardware through an API, SNMP, or even just a direct web browser interface.
Oh, so they're not physically in the room.
Exactly. Instead of physically plugging and unplugging cables in a hot server room, engineers can just sit at a laptop and digitally route those heavy 4K streams anywhere in the building using software.
Amidst all these dense technical specs, there is actually a very human element to this source material.
Oh, yeah.
Yeah, the product has a 4.7 out of 5 overall rating on the HDTV Supply page. And there's this highly relatable review from a user named John M., who gave it 5 stars, but noted, quote, "When I called, the staff was less than friendly, but answered my question."
That is so funny. Even when you're dealing with cutting-edge satellite gateways and complex IT routing, at the end of the day, you still just need a human to pick up the phone and help troubleshoot your rack.
So what does this all mean for you listening? Next time you see that flawless 4K broadcast on a massive video wall, you'll know exactly the kind of silent, high-bandwidth gateway catching that waterfall of data in the back room.
Yeah, it's the invisible bridge between the satellite in the sky and the screen right in front of you.
And it leaves me with one final thought to mull over. If local gateways like this are already this efficient at translating uncoded satellite signals into our local networks, how will this hardware evolve when global satellite networks eventually become the default backbone for all our internet data? Something to think about. Until next time, keep exploring.